So here's just a review video on solutions and mixtures. This is the video that I posted as an Edpuzzle last week. So we're just going to go over a review because you'll be needing it for the rest of the week. So we have mixtures. Mixture is just material made up of two or more different substances which are physically combined, not chemically. That means there's no chemical bonds being formed between their atoms. They just occupy basically the same space. And how you could describe mixtures is by saying they're homogeneous or heterogeneous. So homogeneous, if you remember, is something that is mixed well. That means everything is dispersed evenly throughout the material. So think of milk. You have cream, fat, and butters in there, and it's dispersed evenly throughout that liquid, which makes it all white. Now contrast that to heterogeneous, meaning that it's not mixed very well. So you can actually see there are separate large groups throughout the material. So think of salads. You can see the material not being quite dispersed. You might have some lettuce piled in one area while your croutons and cheese could be in a different area. It's still as a mixture, it's just not mixed very well. Now you have three types of mixtures. Colloids. Colloids are heterogeneous or homogeneous mixture in which the particles are mixed but not dissolved. So when we looked at that Tyndall video, that's more to what colloids are. So think of milk and shaving foam. Those are very good examples of what they are. Now suspension is just a heterogeneous mixture in which some of the particles will set out. You can actually see some of the particles being pushed out. Think of oil and water. And then we have solutions. Solutions are just well-mixed mixture in which particles are small and dissolved. Now, what we talk about when they're small and dissolved and what actually makes up a solution, there's two things we need to know. So we know they're well mixed. So you have something called solutes, which is just a substance that dissolves into a solvent. This could be a liquid, this could be a powder, this could be something solid, but it's going to go into the solvent. Now, the solvent is a substance which the solute is actually dissolved. The widely used solvent is water. That's why it's called a universal solvent. Most everything we have will mix with water and dissolve actually in it. So when you want to think of what's your solute and what's your solvent, think of making Kool-Aid mix. You have your flavor pack, which is the powder, and your sugar, which is another powder. Those are your actual solutes. And what you're going to dissolve it into is your water, and that's your solvent. So that's what you want to think of when you think of solutions. Think of the Kool-Aid mix. Now we can describe the properties of it called solubility. Solubility is a measure of how much solute you can actually completely dissolve in a solvent. Now you have soluble, which means it can dissolve into another substance. Insoluble means it cannot dissolve into a specific solvent or substance. And there is an actual rate. Things could actually dissolve faster or slower depending on these two factors. One is particle size. If you have smaller particles, that means you have more surface area that comes in contact with the solvent, therefore it can dissolve faster, versus if you put one chunk inside, there's not a lot of surface, so it has to kind of work its way through the chunk to dissolve. Another thing is temperature, because remember, in higher temperatures, atoms tend to move around more. And if they're moving around more, they're probably colliding more. So if they're colliding more, that means the solute particles inside are starting to collide with it. Therefore, they're mixing much, much faster. In colder solutions, that wouldn't be an issue. Everything's moving much slower. Now, solubility is an expressive terms of solute per 100 grams of water. Most everything, like I said, it's a universal solvent, will dissolve into water, so that's usually the standard we use. So if I were to say I can only dissolve 10 grams of sugar into 100 grams of water at 20 degrees Celsius. So I have to give a specific temperature when I can do this. And it can only state I can only put 10 grams. Now, if you read below, if I tried to put more than 10 grams of sugar into that solvent of water at 20 degrees, the excess sugar will just settle to the bottom. So it will only take the 10 grams it could dissolve. Anything over that, it just kind of settles at the bottom. When this happens, it's called a supersaturated solution. That means there's so much solute in there that it can't dissolve it all. Now, if I were to put less than the 10 grams of sugar and the 100 grams of water at 20 degrees Celsius, then nothing would really settle out. It would be dissolved, but it's not at its limit of holding the solute. So I could put more. So you want to think of, again, like Kool-Aid mix. If you have Kool-Aid mix and you add a whole bunch of water, you don't have a very good Kool-Aid mix. It's very dilute. You can't hardly taste the flavor or the sweetness. That would be your undersaturated. Now, if I take a whole bunch of Kool-Aid mix and put it into a small amount of water, what happens is you get so much flavor and so much sweetness that it's almost gross. That's your supersaturated. So those are the things you want to learn about solubility, because what we're going to do is we're going to see how much solute we can dissolve into how much solute we can actually dissolve in water by using graph, something called a solubility curve graph, and that will be tomorrow's work.